When the ground beneath our feet breaks, it reveals a terrifying reality. The Earth is constantly tearing itself apart. The continents we stand on aren't permanently fixed. They are fragile rafts surfing on a massive, pressurized ocean of boiling rock called the mantle. Because of this extreme environment, the global map we know today is completely temporary. Land is continually born in fiery eruptions, while old continents are slowly dragged away and swallowed whole. What kind of invisible internal machine drives this relentless cycle of destruction and rebirth? Tracking the mechanics of this violent engine is the only way to explain why Earth, alone in our solar system, remains a living, breathing, rocky planet. Deep inside Earth's core, the radioactive decay of elements like uranium acts as a planetary furnace. This intense heat softens the overlying mantle into a churning pressure cooker. At the mid-ocean ridge on the left, escaping thermal energy pushes magma upward to form new seafloor crust. On the right, older oceanic crust plunges beneath the continent. This creates slab pull. The sinking rock's extreme weight drags the plate downward into the mantle. This subduction process is brutal. Melting under extreme pressure, the sinking rock triggers massive earthquakes and forces explosive volcanic ash plumes straight through the surface. Powered by internal heat and driven by gravity, the Earth's crust operates as a giant continuous conveyor belt, always creating and always destroying. Today, GPS satellites can track these plates moving in real time, but a century ago, geologists like Alfred Wegener had to rely on physical anomalies, observing coastlines fitting together like a jagged puzzle, and spotting identical fern fossils separated by thousands of miles of ocean. The definitive proof of these movements was eventually found underwater, where the ocean floor acts as a massive tape recorder for the Earth's magnetic field. As magma emerges and cools, internal magnetic minerals freeze in place. Because Earth's poles periodically flip, the seafloor records alternating stripes of normal and reversed polarity. This zebra-like pattern perfectly mirrors itself across a mid-ocean ridge, proving new rock is constantly emerging and spreading outward. In the 1960s, a deep-sea drill ship called the Glomar Challenger confirmed this model. By extracting long core samples, they proved that ocean rock gets progressively older the further it travels from the ridge. Tracing these magnetic signatures backward through time, scientists reassembled today's fragmented landmasses into the unified supercontinent of Pangaea as it existed 300 million years ago. This physical record on the ocean floor linked the current movement of the plates to the long-term history of the Earth's surface. Compared to the dead, rigid crusts of Venus and Mars, which lack the heat and water to move plates, Earth's active surface is completely unique. Our violent tectonic system actually functions as a planetary thermostat, regulating the amount of carbon dioxide in the atmosphere over millions of years. As oceanic plates subduct, they drag carbon deep into the mantle. By later venting that carbon back through volcanoes, the Earth manages its own greenhouse effect, preventing the planet from boiling away or freezing over as the sun's brightness changes. This recycling depends entirely on liquid water, which acts as a critical lubricant that allows these massive rock plates to slide and subduct efficiently. This constant geological recycling prevents the climate from spiraling into uninhabitable extremes, maintaining the temperate conditions necessary for complex life to persist for billions of years. This relentless engine operates on a massive timeline known as the Wilson cycle, a pattern taking hundreds of millions of years, where continents break apart, drift, and inevitably crash back together. Far in the future, the Pacific Ocean will permanently close as the Americas aggressively smash into Asia, buckling the crust upward into impossibly high mountains. Roughly 250 million years from now, this collision will complete the formation of Earth's next great supercontinent, Pangaea Proxima. To maintain its delicate environment, the Earth must operate as a living entity, one that continuously destroys its own surface, just so it can be born again.